We've got four methods of solving quadratics. We started with factoring, usually going to be our fastest method. Problem is, not everything can be factorable, and some things are just more annoying to factor than they're worth. Okay, so when we can, we want to try and see if we can factor, but if not, then we're going to move on to something else. Square root property is the easiest, but it requires your quadratic to be in vertex form, and very few times are we given quadratics in vertex form, so it's not reliable. Completing the square is what we use to get our quadratics in vertex form, so we can use square root property, but it is the most time consuming. Honestly, you're probably never going to use completing the square for actually solving quadratics. We're going to be using that process though when we get to circles and other conic sections later in the year. So knowing what it is and how to do it is important. Then our catch-all tried and true method is the quadratic formula. Um, Again, it can always be used, but if we can quickly and easily factor, that's going to be our best bet because the quadratic formula will actually take longer and it has more room for error with all the calculations within the discriminant. So we have to be careful about that. So most of the time, we're going to be either factoring or using quadratic formula. So we have a ladder leaning against a house. Draw a picture. It's going to help with the visualization. Doesn't have to be Rembrandt quality. Okay? We have a ladder leaning against a house. The distance from the bottom of the ladder to the house is 5 feet. The distance from the top of the ladder to the bottom or to the ground is 1 foot less than the length. And we have the length of the ladder. And we want to solve for how long is the ladder. What can I use to represent the length of the ladder?
L minus one. Oh, wait, no.
Well, think about it. If something is going to be L minus 1, just not the ladder, what's going to be L minus 1? Okay, so if this is L minus 1, 1 less than the length of the ladder, what are we going to use to represent
L.
the length of the ladder? Just L. So we've got our expression. All right. What type of triangle do I have here? A right triangle. Given three sides of a right triangle, what can I use to solve for the unknown? What part of trigonometry?
Python theory.
Yeah, our Pythagorean theorem, which is what?
Cosine.
Nope.
It's like
Good.
from the head.
Sides of a right triangle, a squared plus b squared equals c squared. Pythagorean theorem. One of these sides specifically has to be C. The other two doesn't matter which one's A, which one's B. So what has to be side C? Why is it this L? Why this side?
Um,
Well, this side's also unknown.
that relies on length of ladder.
Yeah, which is the longest side. How do I know that that's the longest side? Yep, it's across from our 90-degree angle. So that makes it our largest side, which in this case will be C. And so we've got L squared for C. The other two doesn't matter which is which. We'll just fill in the other two sides. Go ahead, expand the left-hand side. Expand and simplify the left-hand side. What do we get? Say again? Yep. You're missing a term. All right, and we simplify left-hand side. What do we get? Okay, now what?
Over L.
Care to elaborate on that?
Um,
Care to elaborate on that? I mean, we could, but it's not going to get us any closer to what we need to do. Can't square root both sides.
Move the L2, other L2.
We've been solving quadratics for a while, y'all.
Oh, you gotta
I can't do the quadratic formula in its current state. Make it 0. How do I make it equal 0?
put L square on the other side.
Yeah, and then you like backed out halfway through. So what's gonna happen? Can you go back 2 steps and walk me to get there again?
You have to put the 2L on the other side and it becomes positive. And then you have to divide the 2L.
So when we combined our like terms, the quadratic went away. So we just had a linear equation. We're just gonna solve, and we get 13 feet. 1, length can't be negative. 2, no matter how you do this, you can either, here what we did is we added 2L to the other side. Now everything's positive. So when we divide, it's still positive. If you decide to move the 26, you have negative 26. We'll divide both sides by negative 2. You still get positive 13. There's a typo on this. You're going to want to fix it. This should be a 40, not a 30. Everything else is good, though. Suppose a pool is 20 feet by 40 feet. Yep, because the pool is 20 feet by 40 feet. The homeowner wants to plant a strip of grass around the edge of the pool. There is enough seed to cover 700 square feet. How wide should the strip of grass be? What information are we going to need to know in order to answer this question? Ultimately, the answer. X is the width of the grass.
So area.
Okay, we'll need the area of the pool.
And then the area.
Okay, the area of the grass. You need something else.
The diameter of the pool.
That falls under area of the pool. We'll need that. Yep. Um, Not explicitly the perimeter.
Wait, the length of the grass.
Okay, so the length of, are you talking about like this part here?
Yeah, that falls into area.
Partially, yeah. Mm, that's going to be part of the area of the grass. This part right here? So we've got 2 rectangles here, right? That,
You need to know the difference between the area and
you're very, very close. You are very close. Think of it this way. The area of the grass is just this part right here. That's what we're solving for. So the area of the grass is just this part here. The area of the pool is this part here. And the total area. The total area is all of that together. If I know the total area and the area of the pool, what do I do with those in order to get just the grass? Subtract them. Okay? So how do you find the area of a rectangle? Length times width, right? So we're going to have length times width of the total minus length times width of the area of the pool, and that's going to give me the area of the grass. Okay? So what's the length of the total area? 40 plus 2x. What's the width of the total area? It's 2x. What's the length of the pool?
40.
What's the width of the pool? What's the area of the grass? Is it?
Oh, wait. 2x times 2x.
Mm-mm. Read the question again.
700.
700. It can only be 700 square feet. That's the amount of seed they have. 700 square feet. All right. Go ahead and expand out the left side. Good first step. Yep. All right. So we multiply, we expand, we combine like terms, we simplify, we set equal to 0. Now what? How? Solving. Any ideas? We could do that, but those are big numbers. Okay, what's our first part of factoring? Do I have one? 4 will go into 700, yes. Yeah. There you go. I've done this 3 times today already. Let's factor it. We'll get plenty of chances to use quadratic formula. Let's practice factoring. What do I need to do?
Oh, you got
Okay. Okay. Close. -5 and 35. You said 5 and -35. Okay. So what does x equal? So then how long should the strip of grass be? I'm asking for the length of the strip of grass.
Oh, so 45, and then it'll be 5.
What's going on?
Because you
X equals 5.
so the length would be
So how wide should the strip of grass be? 5. X equals 5. X equals 5. And that's not asking for the total. It's asking how wide should the strip of grass be? That distance there, 5 feet. That can't be negative, so we ignore it.
Wait, hold on. Go back up.
A ball is projected upward from the ground. Its distance in feet from the ground at t seconds is modeled by s of t equals negative 16t squared plus 64t. At what time will the ball be 32 feet from the ground? What are we solving for? So what specifically am I solving for? Time, which is represented by what variable? T. Solving for time, that's variable t. So we're solving for those. Which means they had to give me information about s of t. What does s of t represent? Distance. Did they tell me a distance? You sure? 32 feet. When will it be 32 feet off the ground? Now what? Just guessing numbers? That sounds really ineffective.
One, two, three, four, five. We should be able to find it out. No?
What if it's a decimal?
You so
Now what? Set it to 0. Next. Let's do negative 16. Just makes that leading coefficient a little bit better. Okay? Does negative 2 times negative 2 equal 2?
Wait,
It has to multiply to 2, but add to negative 4. Multiply to 2, but add to negative 4. You can't do it. So then what do? Can't factor it.
quadratic
Quadratic formula. Now, fun fact. If you can factor out the GCF, the solutions for this polynomial will be the same as the solutions for this polynomial. So we don't have to use the bigger numbers. So it always helps to factor out your GCF even if you can't factor it. Makes it a lot simpler. Smaller numbers make your life a lot better. What's that first part simplify? What's my discriminant? And then our denominator's 2. So, since my discriminant's 8, how many and what kind of solutions will we get?
Two rational solutions.
One rational.
Can you square root 8?
Nope.
So then are we going to have rational or irrational answers?
Irrational.
Irrational. How many?
One.
2. We will have 2 irrational solutions, which is why you can't guess the check, because your answers are going to be decimals. So, because we know our answers are going to be decimals, we know we're going to have to use our calculator in order to evaluate the square root of 8. So because we know we have to use our calculator, we don't need to bother simplifying the radical because we're not going to be able to use an exact answer. If I asked how many seconds, and you said 2 plus the square root of 2, I don't know how many seconds that is. That exact answer doesn't do me any good. So you're going to want to make sure you pay attention to directions which will tell you where to round. If it tells you where to round, you don't need exact answers. You don't need to simplify the radicals. If it does not tell you to round, you need exact answers. So I'm going to tell you I want to round to the nearest tenth. So we're going to go ahead and solve two different problems. We're going to solve 4 plus the square root of 8 divided by 2 and 4 minus the square root of 8 divided by 2. Be very, very careful how you put it into your calculator because, wrong button, that is wrong. What did I do wrong? Or why is it giving me the wrong answer?
That math.
What should be happening?
4 plus the square root of it.
What's happening in my calculator?
It's doing the square root of 8 divided
Yeah, so it's dividing first before doing the sum. So we need to make sure that that gets added first. So we could use parentheses. We could also just do it in 2 steps. Either one is fine. So we can have 4 plus the square root of 8, get that answer, then divide it by 2. Or we could do 4, I'm just going to change the minus to save us some time. Okay, 4 minus the square root of 8. Well, if we get that formatting right, divided by 2. Either of those methods will work. You can do it in 2 steps, or you can put in the parentheses so that you have that numerator evaluated first prior to dividing. So, round to the nearest tenth, we get 3.4 and 0.6. So, at what time will the ball be 32 feet above the ground?
3.4 seconds.
Just then? Why not 0.6 seconds? It's negative?
Well,
Well, it looks positive to me. Is 0.6 a valid answer?
no,
They're both irrational.
no, but I'm saying
Mateus, you said it is valid. Why do you think it's valid?
Positive.
Okay. What's happening to a ball that gets launched up into the air? Okay, then what?
it comes down.
So, is it possible that it could reach 32 feet twice during its travels? It can go up, hit 32 feet, hit 32 feet, then keep going, and then come back down. So as long as the time is valid, i.e. they're both positive, then that means it's going to reach that height at 2 different points in time. So both solutions are valid. 0.6 seconds and again at 3.4 seconds. It's twice. So we have a formula for the number of corporate bankruptcy filings X years since 1990. So f of X models the number of bankruptcy filings X years since 1990. We want to find the number of bankruptcy filings in 2000. What am I solving for? F of X. Bankruptcy filings is represented by f of X. So bankruptcy filings is f of X. What does X represent?
10 or years.
Years since 1990. The year 2000 is 10 years after. So X equals 10. So we need to evaluate for f of 10. 3.37 10 squared minus 28.6 times 10 plus 133. Go ahead and evaluate. What does it give me? The number of bankruptcy filings in the year 2000? Double check that. You're close. In what years were there about 100 company bankruptcy filings? What am I solving for? So what is 100 then?
Um,
Which is what part of my equation? F of x. Okay. Now what? Yep. Set it equal to 0. Now I've got this god awful equation with a whole bunch of decimals. So what's the best way to solve? No point in trying to factor. It's going to be more effort than it's worth, assuming it's factorable. So we'll be better off just going straight into our quadratic formula. We get memory 7.1 something, and we get 1.4 something. So I get like 1.38. So, in what years were there 100 company bankruptcy filings?
1992, and
Don't round.
what?
Don't round. Or, I mean, I guess round down to the nearest year.
1991,
Mm-hmm.
1997.
If we're making an assumption that point 0.1 is some number of months in, that means it happened in what, January of 19. So that's still the year 1997. Point 0.4 would be, I don't know, around May of 1991. So still the year 1991. It happened during that year. So even if it was 1.9, you still wouldn't want to round up to the next year. It still happened in 1991, just happened to be the end of the year 1991.